So our next speaker is PY from Square. PY has just returned from his honeymoon. Congratulations. Before he left, he proactively had said to me that he would come back to the US on November 1st. On this past Sunday, I got an email from him. I made a note that I was going to email him on Sunday night. I was like, once he's landed, jet lag is a little bit done, he should be a little bit awake. Sunday morning, he sent me an email and he said, you must be really worried about the slides, but I'm not. PY is well known in the Android community. We are so thrilled that he could join us here. PY, stage is yours.
All right, so my name is Pierre-Yves Ricau, but I asked no one to try to say that. It's fine. PY is totally good. You can also call me Pierre. So I am a software engineer at Square. And so today I am not going to talk about how Square uses Bugsnag to release and do the whole release process, because Jordan covered it well. We pretty much do the same thing, so I don't need to talk about that. Instead, I'm going to show you some code and talk about hacking Bugsnag for fun and profit. But in the good sense of the word hacker, not like how to break down Bugsnag or how to pirate it, but instead the definition of a hacker, which is a skilled computer expert that uses their technical knowledge to overcome a problem. I'm reading my notes, obviously. So how many of you here have written code in their life? Maybe right now, maybe in the past. I'm seeing 0 hands. Okay, most people, that's good. All right, great. So I'm going to show you a bit of code, but don't worry, it's not going to be too complex. So at Square, we manage payments. So this is our latest hardware. It's an Android OS that also runs our app, and it takes payments. And so early on, we started using Bugsnag. For us, crashes are very important, because you can imagine that if I'm trying to take a payment and the app crashes, then that's a very bad look. Like, where did the money go? Did the payment go through? Do I give you the item or not? So it was very important for us. And before diving in more into how we use Bugsnag, it's interesting to ask the question, what is a crash? And more specifically, what is a crash on Android, which is the platform that I work on? So how many people know how crashes work? And, oh, okay, I have James, the CEO, knows. Great. So let's dive into that. So from a user perspective, you might know that on Android, what you'll get is this dialog that says, unfortunately, this app has stopped. And it goes away. So from the user perspective, that's all that happens. From a more technical perspective, as you may know, on Android, every app is a distinct Linux process. Every app is a Java VM, really. It's called a Dalvik VM, but it's like a Java VM. And a crash, well, there's two kinds of crashes. There's native crashes, which is what you see usually in games, where the OS sends a signal to the process, and the process instantly dies. You actually won't see a dialog there. You'll just see the app go away. And then there's a Java crash. So what is that? Well, it turns out in Java, you have a thing called an exception. And it's amazing. It's a way to escape the code flow. But what happens when you start a thread, and in that code, there's an exception that pops up and it's not code, then it goes up to the root. And what happens with a thread that terminates with an exception that is not being caught? Well, we can look into that. The code that manages thread will actually call the thread uncaught exception handler, unless there's none, which most of your threads, unless you set one, there's none. In that case, it goes to the default exception handler of the VM, of that specific app. So what is that default? Well, it turns out that Android apps are just good old Java apps, which means they have a main function that you never see as a developer, but it's there, it's in the open source code. And therefore, that main function, when it gets called initially when the program starts, does a command init, and it sets an uncaught exception handler. And what that uncaught exception handler, when it receives an exception, does two things. It logs the stack trace to logcat, which is extremely useless when it comes to user devices because you're not connected to their local logs. But that's what it does anyway. and then it displays the error dialog that we just saw in a blocking way. And when the user presses OK, then that's how the process dies. It just kills itself twice, just to be sure. So that's how Android, handle crashes by default. But what about Bugsnag? Well, that's the great thing about Bugsnag. The clients are open source, so we can go and have a look. And guess what? The Android client has an uncode exception handler, and they replace the default and log the thing to Bugsnag, and then delegate to the default, which will kill the process. All right. So as I said, it's open source. A couple years back, when we looked at what we were using and what we were going to switch to, one of the big selling point with Bugsnag was the open source aspect, because at Square we have opinions about how code should be written, and it's when you integrate third-party libraries, you could have the best code in the world, and then you have a third-party library that introduces crashes or does random behaviors. So it's very touchy. We're like, which one should we use? We loved being able to look at the code of Bugsnag and being able to say, OK, it's good enough. It's not perfect. It's good enough. We were able to verify, and more importantly, we actually were able to contribute. So I looked at the contributors. There's 31 contributors, and 5 of them in the whole history of this client were from Square. So it shows that we were able to contribute back fixes and maybe introduce more bugs. I don't know. So I want to show you a few things that we do with Bugsnag that might inspire some ideas for you, reuse some of those concepts. So of course, you might know by now that you can add metadata to your crashes. They have an interesting concept, which is instead of being a key and a value, it's a tab, a key, and a value, which means you can structure the information and group it together in various tabs. And so over the years, we've added a lot of information. The way we think about it is, for every crash, you should ask yourself, is there information that I missed that I wish I had there that would help me solve that crash? If there's information that I wish I had, then I go in the code and I add it, and next time I'll have it. So some examples, every time an app starts with a new version, we actually store that on the file system. And that way we know which versions the app went through. Because on Android, you can skip versions. So if the user doesn't update and then you publish 2 versions in a row, they might update to the latest one, which means you have to manage the ability to, if you're switching how you're serializing stuff, you have to handle, I'm jumping from version 10 to version 20. And so that was very useful in understanding the upgrade path. And so we log whether the start is just a normal start or it's the first start after an upgrade. And that's an interesting way to look at some crashes. Another thing we did a while ago, I worked on the team that built, so initially Square was just on mobile phones and we built support for tablets. You may know that on Android, there is no such thing as a tablet. Android tablets are a lie. Because the Android team decided, no, we don't want to support tablets, we want to support any device, any size of device. So the industry generally accepts that a device that has a smallest width than 600 dp is a tablet, so that's a unit. So if you take something that's like this, it's not a tablet, but if you make it slightly wider, at some point it becomes a tablet. The concept is a bit weird, but so we introduced that flag because we were like, no, we want to know, we have a design for tablet and a design for mobile, and we have different code paths, so we need to know if a crash happens only on tablet or only on mobile. It's useful information. Similarly, on Android, the keyboard is a mess. It's really, the APIs, well, there's no API. And every keyboard can cause your app to crash in a very different way. So it was interesting to report the keyboard that we use so that we could see patterns and see if a crash happens on one specific, when using one specific type of keyboard. Another piece of information we added was with the introduction of permissions on Android. Permissions introduced a lot of crashes in Android apps when they appeared, because you basically try to do something and all of a sudden you get a crashing like, no, you forgot to ask the permission. So this was a way for us to understand, okay, what was the permission when the crash happened? We also, so you may know that Bugsnag has the notion of breadcrumbs, but when we started using them, they didn't. And so we made our own, which shows the flexibility of the tool because, theirs is better because it has color. But other than that, so we made our own. And what's interesting here is we log server calls. So and we log the status code. And so that's actually, when I see a crash, I always go to the last thing that happened. And if I see a couple of crash instances and I notice that there's always the same server call and it ends with like, a 400 or something, I'm like, oh, that's an edge case that someone forgot to handle this error case. So that's always useful information. And we also log screen navigation. On Android, you have activities and fragments, and Bugsnag can automatically scan into that, but more specific inside the app, screen navigation, they don't have that information, so we add it for ourselves. There's another thing that I love about it. It's something that we discovered kind of by surprise. It's a little secret that you may know, but Bugsnag, in their metadata, they preserve new lines. So what does that mean? It means you can have ASCII art. So you can do that, which this is square, if you can read. That's not very useful, obviously. But the way we use that is we print the view hierarchy directly in the crash logs. So here, I can see that I have two activities. We can zoom in maybe and see. It's like the file system when you represent the live file system in the console. So you can see all the views, their IDs, their size, whatever information we want to put in there. If you're interested in the source, this is my interview problem, so I'm not going to share the source. However, I can give you pointers. In the Android Espresso test library, there's a class called Roots Oracle, which is used for UI tests and basically gives you access to all the root views of all the activities. It's using a lot of hacks and reflection, but it's managed by Google, so hopefully they don't break it. So that's what we use to get started. Okay, let's talk a little bit about custom filters. That metadata, you can add custom filters on it. I think the default is 10, and I always send emails to James asking for more every now and then. But that's actually super useful. So one of the things you can do, and I think we saw that, is you can assess whether for a specific piece of metadata, you can say, is this crash happening 100% on this? What's the distribution? That's super useful to understand the context. And similarly, we do the same thing where we go and search for a specific device or a specific user. The device serial number is interesting when you have different apps because you can kind of cross-reference and understand, is this user seeing other things? All right, so I have a few more things I want to talk to you about. So Bugsnag has this API called before notify, where you can actually completely transform a crash, which is a stack trace plus a bunch of metadata, before it's being sent. You can even stop it from being sent. It's a great API. We don't use it because I guess we started with something else and we kept using that. But in a similar spirit, we install our own exception handler and delegate to Bugsnag. And so before delegating, we do our own transformations. So there's some interesting stuff here. It's a little bit cut, but we say, oh, is this an out of disk space error? If yes, well, we're going to crash anyway, but we're going to show a notification to the user before telling them, hey, you're running out of space. Sorry, we're crashing, but you should probably remove some stuff. Because we're dealing with payments, people usually uninstall the other apps, so we get to win no matter what. So same thing with read-only file system, similar thing. And we also log them as warning instead of error because there's not much we can do about that. One of the more interesting ones is out-of-memory error. So it's kind of my area of specialty these days, or the thing that I'm known for in the Android community. So on Android, an out-of-memory error is a very specific thing, and it's kind of different from, say, iOS. So you're trying to do something. You're trying to create a new object or allocate a bitmap or doing something like that. And there was not enough memory for it, and so an exception was thrown. The big thing to remember here is that 99% of the time, when we try to allocate memory and it doesn't work, the problem is not that we try to allocate memory. The problem is that we don't have any memory left. So this stack trace, this crash could happen when you're running out of memory and you have only a few kilobytes left. This could happen anywhere. I could be creating a string. I could be logging something. And so you have all these stack traces that are all different because you're running out of memory. And 99% of the time, your real problem is you have memory leaks. You have allocated memory, created objects. You don't use them, but you're keeping references from them, so the garbage collector is not cleaning them up. And you're accumulating those memory leaks, and then eventually you run out of memory. And initially for us, what was a big problem there was that every different places where it would crash, which is anywhere in your code, really anywhere, would lead to a different stack trace, so you get a different entry in Bugsnag. And so this will never be prioritized because it gets to the long tail. So what we did is we decided to group them together, and I'll get to that in a second. But the first thing we did was, how do we solve this problem? Well, we need to fix memory leaks. And so this is where I introduced something called Leak Canary. I'm not going to talk about that in details, but if you're using Android or really any sort of Java VM, there's this tool that I built. It's shared in open source that will detect memory leaks and provide you with feedback. We use it in debug. It's freezing the VM and analyzing the memories. So you don't want to do that while the user is taking a payment. But however, it's very useful to do in debug. So what do we do with those out of memory error? When we get them, we create a fake stack trace. And we say, hey, we ran out of memory, but here is a fake stack trace. The class name is just out of memory error, or I don't remember what it is. And then the method is fly canary fly, and the line is 0x dead. And it's just a fake stack trace, and we tell people, you should go fix the memory leaks. And so in Bugsnag, then we end with this one-line stack trace that is very clear. And even our ops team will sometimes see that. They'll search for this in Jira and find that one place and say, hey, it went up again. So that's pretty much it. To kind of summarize, I think one of the things that you came across for all these different talks is that keeping a low crash rate requires investing, not only in the pipeline and the tooling, but also kind of always digging deep, investigating, and trying to get more information about the context of when the crash was happening. And if I have one thing I would like to, you to leave and think about is to think about reading the source code of the framework and the tools you use when you can, because you can learn a ton from that, and you can create even better things. That's it. Thank you for your attention. If you have questions.
I haven't done much Android development, but are the memory pools shared across applications, or is the memory leak going to be from your application when you get those out of memory errors?
That's a great question. So no, it's not shared. Really what's going on is that when the Android device starts, you have one process that started, it's called the zygote. And every time you start an app, so that process is a Java VM starting, it loads all the the framework classes from Android. And then when you start an app, it's actually a fork. So it forks that process into a new process. And that process gets allocated some amount of memory. So a leak in one app is not going to cause any problem. It does cause problems because as apps use memory, then your system is more constrained and start shooting, various apps. But memory leaks are caused by your own bugs and the bugs that exist in the Android framework.
So you mentioned doing your own pre-processing, and also that the out-of-memory errors, the stack traces, aren't particularly useful. So you're overriding them with something that's common to all of them. But I was wondering if there were any other reasons why you opted to not use the custom grouping hashes in Bugsnag.
That's a great question. And so to kind of give context to people, in Bugsnag you can say, so by default, Bugsnag will come up with a way to group your stack traces. They call it smart grouping. Air quotes. I don't know how it works. I think it's smart, probably. But I think it does a bunch of things. We're trying to identify what's part of Android, what's part of your code, that kind of stuff. And you can override that and say, no, I know how to group things. I'm going to give you a hash code, and use that hash. I could be wrong here, but I think the main reason we don't do that is because it's an all-in kind of approach. And we actually like those smart grouping. It's basically we want an exception to that smart grouping just for out-of-memory errors, a few other things.
Hey Pierre, thanks for your presentation, and especially for explaining the two crashes or crash versus process getting killed by OS. For the case with OS killing the process, we had this recent issue where even when our app is running in foreground on Samsung 9.0 devices, it's getting killed. So they are being aggressive. If we are doing a lot of things in background, it's killing us. Is there a way through Bugsnag to figure out what exactly are we doing in that instance where this may be happening? So this is the other case, right? It's not a crash with an exception.
This is really interesting. So I have, okay. So Samsung does all sorts of crazy things in their versions of the Android OS, but processes have priorities, and in theory, being in the foreground gives you the highest priority, which means you should never be killed. Everything else gets killed before you. You may be killed because of other reasons. Native crashes. There is the native code is different for every vendor. So there could be something that would be killing you. I'm not aware of any way that the Android OS would deliberately kill your foreground process, and I'm not aware of how. Maybe someone from Bugsnag can talk about that a little bit later. But I don't think it could, because the thing that when that happens, you get a signal to the signal handler, and then you're dead. There's not a lot of room for that. Sorry.
Just curious, what's your guys' goal for stability for tablets for accepting payments, or like what do you guys maintain it at? Like,
I can probably not answer that question because it would get me in trouble. I'll give you kind of a high-level answer. We actually don't use the stability score or that part of the dashboard, mainly for historical reason. The concept of handled and unhandled exception didn't exist initially. We have our own. We kind of double. We send our crashes to two different endpoints, Bugsnag and an internal one. The initial reason was that you may know with Bugsnag there are limits on the number of events you send, and then it starts dropping, and we didn't want to drop. We want that data, the details to dive into what's going on, but we wanted metrics around like how many crashes that weren't as detailed, so we kind of set up two pipelines. And so our crash rate is computed on this separate pipeline that doesn't go through Bugsnag. So we don't really look at those things, though every now and then, I think at some point we might switch back. I really like the presentation on how Pandora does it, and I think maybe we should consider switching back because it's a pain right now. But so we don't really use any kind of like score like that. Or we have our own internal metric, but I can't really give you any number. All right, I think that's it for questions. Thank you.